Alright, logic fans, welcome to our third video, 5.5c on section 5.5, and we're continuing our study of central semantic concepts, moving into a new semantic concept, the notion of semantic logical consistency, or semantically logically consistent. And this does follow the definitions of propositional consistency given in chapter 2. There we saw that two propositions are consistent provided it's possible for both of them to be true. And we get a very similar definition here, which says a pair, so two sentences that you just pull randomly out of a hat, like these two, are semantically logically consistent if and only if there exists at least one interpretation according to which they are both true. Okay, so let's take as an example these two. So here's the categorical I sentence, the categorical O sentence. Are these, what do you think? Are these semantically logically consistent? Yes or no? Pause now. Okay, hopefully you've had a chance to think on that. These are semantically logically consistent, right? There exists at least one interpretation according to which they are both true. Can you provide me with such an interpretation? Prove that they are semantically logically consistent by providing an interpretation according to which they are both true, let's say in two objects. Pause now. Okay, so here's an interpretation according to which both sentences are true, right? So the object A satisfies this description, it's both F and G. The object B satisfies this description, it's F and not G. And so both sentences are true on this one interpretation, and that is the definition of semantic logical consistency. So this sentence is semantically logically consistent with this sentence. These two sentences are consistent, meaning it's possible for both of them to be true. They don't have to be true, as a matter of fact. We can articulate Tableau interpretations according to which they're both false, right? So for example, here's an interpretation according to which both sentences are false, right? Nothing satisfies this description, right? Nothing is F, and similarly nothing is F in this description. There's others too according to which they're both false. The point is that they're semantically logically consistent in the sense that it's possible from a purely logical point of view both could be true. Okay, and we proved that a moment ago with an interpretation according to which they were both true. Now, there is another notion, which is the notion of semantic logical inconsistency. So let's explore that for a second. So the notion of semantic logical inconsistency, new concept, okay, is that two sentences are semantically logically inconsistent if and only if they take the opposite truth value on all possible interpretations. Okay, so this again requires something very strong. Every single interpretation has to satisfy a particular constraint, namely that the sentences take opposing truth values. Okay, so for example, intuitively, these two sentences are semantically logically inconsistent, right? When the one's true, the other has to be false. And hopefully you can see that because you recognize that these two are sort of the form P and not P. So those have to take opposite truth values, right? And so no matter what interpretation you're looking at, if the one's true, the other's false and vice versa, right? And so that's kind of an interesting idea, but we cannot prove that the two are logically inconsistent if we limit ourselves only to semantic techniques explored in this chapter. You will be able to prove that they are inconsistent in a way in chapter 6. So when we start doing syntax, you'll be able to prove that the negation of the corresponding biconditional is a theorem. And so we discussed that in chapter 6. So we can explore related ideas syntactically is the point. But an alternative way of thinking about semantic logical inconsistency is to think that they're corresponding biconditional, right? So these are just alternative definitions of the same concept, okay? They're their corresponding biconditional, which would be this guy. So now we've got a single sentence that's a biconditional, right? Provided this biconditional is a semantic logical falsehood, provided this biconditional here is a contradiction, right? Then we would say that the two sentences are semantically logically inconsistent. They're going to take opposing truth values on all possible interpretations. But as you know, we cannot prove that a sentence is a contradiction, is semantically logically false, even though we can prove that a sentence is not semantically logically false. So I hope that's all making some sense, okay? But that's the notion of semantic logical inconsistency, which we cannot demonstrate, but we can demonstrate semantic logical consistency. And now what I want to point out to you is that we can, and this is sort of building up to the big payoff of the notion of semantic logical validity, okay, or semantic validity in a minute, but we can extend the notion of semantic logical consistency, okay, beyond a pair of propositions, and we can say a set of quantificational sentences are semantically logically consistent if and only if, okay, there exists at least one interpretation according to which they are all true. So instead of just thinking about a pair, like two sentences, we can now think about like 5 sentences or 4 sentences or 3 sentences, and we can ask whether all 3 or all 4 or all 5 of those sentences are jointly consistent, meaning is it possible for them all to be true at the same time, as it were? Is there at least one interpretation according to which they are all true? So let's look at an example of that. So here's an example, right? And we're extending beyond a pair of sentences to think about multiple sentences. And this is a prelude to thinking about, whether or not arguments are valid or not, semantically understood. So a set, in this case 4 sentences, are semantically logically consistent if and only if there exists at least one interpretation according to which all of them are true. So first question for you. Do you think all 4 of these are semantically logically consistent? Yes or no? Pause now. Okay, hopefully you've had a chance to think about it, but all 4 of these are, in fact, semantically logically consistent. There's at least one interpretation according to which they're true. Prove it. Okay, I'm going to give you a hint for that in a second. That is to say, provide one interpretation according to which every single one of these are true. I'll give you a hint in a second, but pause now and see if you can do that. Okay, here's a hint for you. You're going to need 4 objects in order to do it. A, B, C, and D. You won't always need that for proving that a set of sentences are semantically logically consistent, but in this case, with these particular 4 propositions, you do need 4 objects. Pause now. Okay, so hopefully you got it, but here is an interpretation in 4 objects that makes every single one of these propositions true, and therefore the lot of them, all 4 of them, are semantically logically consistent. So object A makes this sentence true. Object B makes this sentence true. Object C makes this sentence true, and object D makes this sentence true. So A satisfies this description. It doesn't satisfy any of the others. B satisfies this description. It does not satisfy any of the others. C, lacking F and having G, satisfies this description, and D satisfies this description, having neither F nor G. Okay, so these are in fact jointly taken together semantically logically consistent. Okay, let's jump into our big notion. All right, the notion we really want to build up to, right? And we'll do that let's just do it on the next video. So we'll have a clean video talking about semantic validity. Okay, catch you on 5.5D.